This is a problem where we have this series, and what they're asking for is what's called an interval of convergence. Interval of convergence. All right, interval of convergence. All right, so what's the interval for x where this series x raised to the n over radical n, what are the values of x where this series would converge? Well, the way we're going to go about solving not just this problem, but a lot of problems like this where they ask for an interval of convergence is you're going to use that limit, you're going to use that ratio test. And the ratio test says that if you take the limit, as n approaches infinity, where you substitute n plus 1, x to the n plus 1, you substitute n plus 1 everywhere where you see n. All right, so substitute n plus 1 here, and we'll substitute n, we got a radical, n plus 1. So I'll write it out. The ratio test says you take the limit as n goes to infinity of a to the n plus 1 over a to the n. If you evaluate this limit and it's less than 1, that says that the series converges. If you evaluate this limit and the result is greater than 1, well, that tells you that this series diverges. And if you evaluate this limit and it's equal to 1, that tells you that this is not an adequate test to use, and you've got to go in another direction. All right, so that said, let's now attack the problem. So this is a sub n plus 1. Let's divide by a sub n, which is the original series. So you got x to the n over radical n. So let's go through that one more time. This a to the n plus 1 is telling you to substitute n plus 1 wherever you see n. And I see n here and here. So that's what I did. I substituted n plus 1 here, and I substituted n plus 1 here. Now this a sub n means to rewrite the original series below that, and that's what I did. All right, so now let's evaluate this limit. We got the limit as n approaches infinity of, let's expand this exponent. We end up with x to the n times x, all right, and that is over radical n plus 1. All right, so one of the things that you should have learned in the past here, where they have x to the n plus 1, you should have learned an exponential property where if you have a to the m times a to the n, that is a to the m plus n. So I'm doing that in reverse. What I have is I have x to the n plus 1. A to the n plus n. If you have a to the n plus n, that can be turned into a product. Where that can be turned into a product. So what I have is x to the n plus 1. That can be turned into the product x to the n times x to the 1. That's what I did here. That's how I got that. So now that's going to be multiplied to the reciprocal of this. So we end up with radical n over x to the n. Radical n over x to the n. And you're going to evaluate this limit. A lot of times what you're looking for with this ratio test, and that's what we're using here. We're using the ratio test. All right. So a lot of times you're looking for cancellation to simplify this limit. So what you experience there is cancellation there. So now what we have is we have the limit. Sorry, I should have mentioned that that's absolute value. Sorry about that. So we have the limit as n goes to infinity of the absolute value of radical n over radical n plus 1 times x. All right, times x. radical n over radical n plus 1 times x. This can be simplified to the limit as n goes to infinity of the absolute value of x. One of the things that you should have learned is the limit of a product is the same thing as a property of limits is if you have the limit of a product, you can take the product of two different limits. So you have the limit as n goes to infinity of just the x, the absolute value, times the limit as n goes to infinity of this radical n over n plus 1. So I'm hoping that you see what I did. I sort of did two things in one. I broke up this limit to be a limit of two products, and at the same time, I used an exponential property where you have a radical on the top and the bottom. You can turn that into the radical of one big fraction. And I hope that's clear what I did there. So now, the limit as n goes to infinity of x, that's just the absolute value of x, because there's no n there. All right, so now what you end up with is the limit as n goes to infinity of this function. Hopefully you can see that that's just going to be 1. The limit of that's just going to be 1. So you get 1 times the absolute value of x. For this series to converge, one of the things that we said in the beginning of the problem is that this limit would have to be less than 1 for it to converge. So what you end up with, if you simplify this, what you end up with, another way that you can rewrite the absolute value of x less than 1 is you can rewrite it as an interval. So let's do that over here. -1 less than x less than 1. It's a compound inequality. Another way to rewrite this absolute value inequality is as a compound inequality. So now the only thing that you have to do now to determine the interval of convergence is to check each of these endpoints of this interval. All right, so let's do that one at a time. Let's substitute 1. Let's see if 1 would, if we substitute x as 1 into our original problem over here, would that converge? All right, so let's determine, let's analyze, let's substitute x as 1. All right, so if we substitute 1 into the series in from 1 to infinity, we substitute in 1 to the n over radical n. All right, that's just 1. That's just n is equal to 1 to infinity of 1 over n to the half. Well, if you study this subject of series, you recognize that that is a p-series. That's a p-series. This is and when you have a p-series and you analyze this term here, when this is 1 or less, when this is 1 or less, you're looking at a divergent p-series. All right, so that tells you that at 1, this series will not converge, so you would not put the equal sign there. You wouldn't put an equal to sign there. So now let's test x equal -1 to check the other endpoint. Let's substitute in n is equal to 1 to infinity. N is equal to 1 to infinity. Let's substitute -1 into our original problem. -1 raised to the n power. And then we have a radical there. All right, so what you're looking at now, when you study this subject of series, that's actually an alternating series. This is an alternating. Anytime you see that -1 to some power to alternate the sign, it's an alternating series. And there are two criterion. There are two criterion to check when you're working with an alternating series. The first criterion is to analyze this series when you've eliminated the source of alternating. All right, so one of the things that you'd have to test, let's act like you've got some series or some function where you eliminate the source of what's causing the alternating on the series. Let's just make that 1 over radical n. And the two criterion is if as n goes to infinity, if you evaluate the limit as n goes to infinity of 1 over radical n, if this is 0, that's the first requirement for you to begin to call this a converging alternating series. And I hope you can see here that as n goes to infinity, this does equal 0. So that's the first thing that you need to check. The second thing that you need to check is if you got this f of x equal to 1 over radical n, and you apply, the second thing is as n gets larger and larger and larger, this function has to be getting smaller and smaller and smaller. And I hope that you see as n continues to get larger and larger and larger, that would force this overall function get smaller and smaller and smaller. So those are the two criterion that you would need to check. The limit would have to be approaching 0, and it does. And then this function, as n gets larger, each of these elements have to be getting smaller and smaller and smaller. And I hope that you see that that is the case. So then that tells you that at -1, this indeed converges. So you'd put an equal to sign. You'd put an equal to sign there, and that would be the actual interval of convergence. If they ask for a radius of convergence, you'd have to see you'd have to see that the distance between these 2 points is 2, and then the radius of convergence would just be half that. The radius of convergence would be 1. All right, they didn't ask for that, but I just thought I'd give it to you anyway. All right, so